Okay, tutorial 8, we're introducing competition. So in the last two videos, we've built up a model of firm optimization behavior. In this video, we're actually going to take those ideas and apply them to a market. So we're going to have a demand curve and a supply curve by the end of this video. We're going to first talk about perfect competition, what that market structure looks like in this context. We're going to talk about profit maximization in perfect competition, and then we're going to build models in the short run and the long run with perfect competition. So that's where we're going. To start us off, the idea with perfect competition, you've already seen some of this in your intro classes. The idea with perfect competition is that firms are price takers, which basically means they have no control over what the price is. Of course, a firm can charge whatever they want, but if they're actually going to sell at the highest possible price, that price is given to them by the market. So what this means for the individual firm is that their demand curve is horizontal. So the price line for the firm is their demand curve. There may be, in reality, some slight a slight downward slope to their individual demand curve, but for the most part, and the way we're going to model firms in perfectly competitive markets is with a perfectly flat horizontal demand curve at the price. And this can come from a number of sources. Probably in most perfectly competitive markets, the horizontal demand curve comes from a combination of many of these. So when we have a very large number of buyers and sellers, we get a perfectly flat demand curve for the firm. This is really just because no individual has any power. When you're one in many, changing your decisions doesn't do much to change the market. We could have identical products, full information, which is really required in a lot of ways for perfect competition. Small transaction costs is important for perfect competition, and then free or at least inexpensive entry and exit into the market and out of the market allows any potential profits to be challenged by new entrants, and any losses to be responded to by firms. So this is the definition we work with in economics of competitive markets, that firms are price takers, and they face a flat demand curve. Okay. Perfectly competitive markets are really nice in a lot of ways. They're somewhat common, but I remember when I was taking this class, I guess particularly intro, I got the impression that perfectly competitive markets were somewhat universal, and they are not. They show up typically when we have commodities. So when we look at goods like oil and grains, those are pretty classically perfectly competitive markets. But perfectly competitive markets are far from universal. The other nice thing about them is that they have nice welfare properties. So we'll talk about this later. But They tend to maximize welfare when we have no externalities. And lastly, it's not one of the main reasons thinking about perfectly competitive markets is important, but they're also very simple to model. So that's typically why we start here. So in the context of profit maximization, we've already defined the profit function, which is this thing. We usually denote it with pi, just because we've already used up the letter P for price, which is just the difference between revenue and their costs, which includes their opportunity cost. And this is the firm's objective function. This is the goal for a firm, is to maximize this thing. We say it's a loss when profit is negative, and they receive a profit when profit is positive. If you want to say a negative profit, that's fine. You might even hear me say that from time to time. A loss is just defined as a negative profit. Okay, so depending how you were taught profit maximization in your intro class, you may have seen this set of steps already. If so, this will be a more formal treatment. If you haven't seen this set of steps, when I teach intro, I teach this as a universal across every type of firm. And I think it's important to point this out before we get into any particular market structure. Here we're starting with perfect competition, but these 3 steps, a 3-step process, doesn't depend on market type. We're going to do the same 3 steps whether we're talking about perfect competition, monopoly, or even firms in game theoretic environments like oligopoly. Here, all we have to remember is that firms face a horizontal demand curve. So we're given a demand curve, and we're applying these 3 steps to it. So when we think about the profit function, we're going to include these 3 components as functions of Q. So the profit is a function of Q, so profit depends on which quantity we choose. The same is true for revenue and costs. Okay, so here are the 3 steps. The first is we choose output. And we're going to choose our output Q as a positive number that maximizes our profit. Second, once we've found Q star, which is our profit maximizing quantity, we're going to choose a P that maximizes Q. For the perfectly competitive firm, this is going to be easy. There's a demand curve, which is just price. So there's no plugging in. When we have a downward sloping demand curve, we simply take our Q, plug it into the demand curve to give us our price. This is saying what's the highest price we can charge and sell everything. For the perfectly competitive firm, this is simply just taking the price, because the price is the same at every quantity. And lastly, once we found this P and Q, we want to decide whether we should shut down. Is it more profitable to produce P or to shut down? Okay, so those are our 3 steps. And we're going to walk through the strategies to solve these 3 steps. And let me just, I think it's worth noting here, I almost even thought about rearranging the class around this point. That no matter what type of firm you are, no matter what market structure you live in as a firm, these are the 3 steps you follow. It just turns out that we're starting with perfectly competitive markets, which makes step 2 look really simple. But in the back of your mind, remember that step 2 is going on. It's just very simple when we're looking at perfectly competitive markets. Because we're going to take these 3 steps and apply them to many other types of markets. Okay. So for step 1, our output rule, there are 3 sort of equivalent ways of thinking about it. The first is just we look at a graph and we, try to find where profit is maximum. We try to look at the graph and find where it is. This works fine. So if you have a table that lists out all the profits, you can just find the one that's maximum. But we have if we know what the profit function is, we have a much more efficient way of characterizing profit maximization. And that's with the derivative. So we take the first derivative of the profit equation and we set it equal to 0. And this is our output rule 2. We set quantity where the marginal profit is 0. The marginal profit is just the derivative of profit with respect to Q. And then, of course, we have our second order condition, just making sure that we're at a maximum and not a minimum, where if we move in either direction, we go down. Okay? But we could take that output rule 2 and rearrange it. So if we were to expand the marginal profit into its 2 components from the definition of profit, we get the derivative of the revenue function with respect to Q and the derivative of the cost function with respect to Q, and we set that equal to 0. And that gives us this relationship, which you might have seen before, that MR is equal to MC. Okay, so this is the point at which we choose our profit maximizing quantity, Q star. Okay, so then our pricing rule is simple in a lot of ways, and it's particularly simple in the perfectly competitive market. All we do is just plug our quantity into the demand curve to give us price. We're just running a line from Q star until it hits the demand curve, and that's our price. In a perfectly competitive market, because the demand curve is horizontal, this is just the price that the firm is given by the market. But we'll nuance this later. Okay, so then our shutdown rules. So let's be careful here. No matter whether the firm operates or shuts down, they still have to pay their sunk costs. No matter what. So to say this more carefully, the shutdown rule for the first shutdown rule is that the firm shuts down only if it can reduce its loss by doing so. If the firm is making a profit, they should continue to operate. But if they're making a loss, we have to consider whether shutting down reduces their loss or not. So we're going to define sunk costs as F. And this is our profit equation, where we have our revenue minus our variable costs and minus our sunk costs. So here, if we shut down, we still have to pay our sunk costs, F. So what we're saying is we should shut down if our negative profit is less than our sunk cost. And we really should say negative F. So this is our condition. So if we rearrange this, we can eliminate F from both sides, which leaves us with R minus VC. And then we rearrange this again, which gives us R is less than VC. So doing this math here, it gives us sort of a more formal shutdown rule, which is shutdown rule number 2, that the firm shuts down when its revenue is less than its avoidable costs, which is VC. Okay. So those are our 3 conditions, our 3-step process for profit maximizing for the firm. So let's look at short run. So the following is sort of specific to the competitive firm because price doesn't depend on our choice of Q. So price is always the same. So this is the definition for revenue in a perfectly competitive market. And when we take the derivative of revenue with respect to quantity, that just gives us the price. When we use this with the profit equation, we get the following. So we know what the derivative of the revenue function with respect to Q is in the perfectly competitive market, which is price. So simplifying, we get this relationship here. And this happens in perfectly competitive markets specifically. Okay. So this is the type of sort of a stylized version of a perfectly competitive market. On the left here, we have our cost curve, C. We have our revenue curve. And the difference between these two is the profit. So at the point where profit is maximized, the difference between cost and revenue is maximized. So this vertical distance here is the profit. You could also see it as the vertical distance. Here. Either way is equivalent. But it's often more useful to think of these markets in terms of the averages and the marginals. So on the graph on the right, we have marginal cost. We have our price. And we choose our quantity where they intersect, right here. Then our profit equation is profit is equal to price minus average total cost times quantity. And you've almost certainly seen this in your intro. So the height of this is the difference between average total cost, or average cost, as we're calling it, and the price multiplied by Q, which gives us this rectangular box here. And that's our profit. For prices that are below our average variable cost point, so if price were to drop below this, this line here, where it intersects the marginal cost, would be our lowest quantity. So what do we call this? Min, maybe. Any price below, we would shut down. Any price above it, we would continue to operate. Okay, so we have our 4 variables mapped out on this graph here. We have marginal cost, average variable cost, and price. And using those 4 alone, we can map out where prices would lead us to shut down, what our optimal quantity is given a price, and what the profit is at that price. Okay. So we can do some rearranging here. This is just dividing the profit equation by Q, which is similar to what we did up here. We just multiply this thing down here by Q to get the area of the profit. The short run decision rule, the short run shutdown rule, we can derive this by taking the derivative, dividing both sides by Q, which is this thing here, which tells us that this is sort of graphically what we saw up above, that whenever the price is below the average variable cost for our profit maximizing quantity, that's when we should shut down. And this is just another way of deriving it. We take revenue less than variable cost, which was our shutdown rule 2. Shutdown rule 2 here. We divide both sides by Q. We rearrange this. So variable cost over Q is average variable cost. And this is quantity times price, which is our revenue, divided by Q, just gives us P. So whenever price is below average variable cost, that's when we should shut down. So what this graph does here, this second graph, it tells us that the price intersecting the marginal cost curve is what determines how much we should supply. And any point below this line here, any price below that, that shutdown rule, we should jump to 0. And this is exactly the definition of the supply curve. Give me a price, I'll tell you how much the firm is going to produce. That's the supply curve. So just to simplify this and show it in a sort of a prettier picture, our supply curve is this red line. When price is below this shutdown rule, we produce 0. And we produce 0 all the way until we reach a price that's at least average variable cost. And then once we're above average variable cost, then we just follow the marginal cost curve. So we get this sort of piecewise supply curve. When the price is too low, we produce zero. And when the price is appropriate, our marginal cost is our supply curve. Okay, so that's for the firm. For the market, the supply curve is just the horizontal sum of all of the firms in the market. We just add horizontally to give us the market supply curve. Okay, so as more firms enter the market, when there are more firms in the market, the supply curve becomes flatter. Okay, so when we think about the supply curve, we think of all of the individual firms choosing their profit maximizing quantity according to the price and the marginal cost. This marginal cost gives us the individual supply curve for the firm. We take all of the firms, we add them up together to give us our supply curve here. When we have a demand curve, which we constructed the past 2 weeks from the consumer's problem, we get this downward sloping demand curve, which is just the sum of all of the individual demand curves. And as you'd expect, when we intersect them, that gives us our equilibrium price and quantity. Okay, and that's what gives us the price. So we get this sort of interlocking relationship between the market and the firm. The firm takes this price and chooses their quantity. And we typically denote the firm's quantity Q star and the market's with a big Q star. We can find the firm's profit, which is this yellow area, and we've paid special attention to this discontinuity for very low prices. Okay. And when all of this is true, we have our perfectly competitive market equilibrium. When we look at all of the firms in the market, we add up all of their supply curves, and we intersect that supply curve with the demand curve to give us the price. That should equal the price the firms are facing. Okay. So that's our market in the short run. In the long run, things become a bit simpler, where above we had to think about shutdown and negative profit. In the long run, all costs are variable, which means whenever a firm is making negative profit or loss in the long run, firms will leave the market. So we're sort of going to abstract, we're going to, in some sense, ignore sunken fixed costs. I'm just looking at avoidable costs, the variable cost curve. And because of this, the variable cost curve is equal to the cost curve because we have no sunk or fixed costs in the long run. And again, we're going to use the 3 optimization steps we used above. We can always use them, no matter what the context. So in the long run, the firm will operate only if their profit is non-negative. And firms will enter the market if there's positive profit to be had, and firms will exit the market if they're making negative profits. And of course, because we're in a perfectly competitive market, we're saying that there's easy entry and exit, or free entry and exit. And since the market supply curve is horizontal, or I should say the horizontal sum of the firms, when we add more firms, the supply curve becomes more horizontal. So as more firms enter, we get this increasingly horizontal market supply curve, which is interesting. So as firms enter, we get a flatter supply curve, and when firms exit, we get a steeper supply curve. So when we have many identical or very similar firms, the entry and exit dynamics sort of lead us to a relatively flat supply curve. So when demand shifts in and out, this doesn't change price very much in the long run, even though in the short run, because there isn't these entry and exit decisions, you can have changes in price. So the sort of intuition here is that in the long run, prices are going to return back to normal, or return back to where they were before the demand shock. And it's going to lead us back to the point where, where profits are equal to zero for the firm. And we'll do some modeling of this as we go through the next sections. But this is the intuition for the zero profit condition. And I'm just going to set it up kind of loosely here, just to give like a bit of a visual intuition for what's happening. We have our demand curve and our supply curve. We intersect them to give our price. And here we have the firm. And we have our price, which is our marginal revenue curve. We have our marginal cost. This is our quantity. And let's say we're in our long run equilibrium. So we have our average total cost, average cost curve like this. Now, when demand goes up, we get the shift out, say D prime, in the demand curve, which increases our quantity. We have Q prime, P, and P prime. And we get it partly because we get an increase in the individual firm's quantity decision. The higher price leading to a higher quantity comes partly from the fact that the individual firm is producing more. And that's where it's coming from entirely in the short run. What this does in the short run is it gives us this positive profit here. But what happens with a positive profit is firms enter. And when firms enter, that shifts the supply curve out. And the only point where firms will stop entering is when the supply curve leads us back to our original price. And at our original price, we end up back at our original quantity for the firm. And that means average cost is equal to price, which gives us profit of zero. And you could run through the same set of steps for a shift in of demand. Okay. So that's where the zero profit condition comes from. And that's how we get this price equaling average cost, which, when we're in a perfectly competitive market, means our marginal cost is also equal to price. So this means you can see it both mathematically and graphically that the average total cost, or the average cost, intersects the marginal cost at the minimum of the average cost, which means we're actually producing at the minimum of the average cost curve, which is really nice. What that's saying is we're picking anywhere on the average cost curve that minimizes how much it costs us to produce per unit, which is actually pretty amazing. Okay, so I'm going to leave it here. We have a demo homework 3 up on Canvas. Take a look there. Solutions are posted as well. I might post some more live math videos walking through some of this, but I think we're going to leave it here for this video. I'll see you in the next one.